Hello students! Today we are going to look at surface area of prisms. The other day we talked about what prisms are already. The special thing about prisms is that you can always find this cross-section which is always congruent. So they are always the same shape and the same size. So if you cut the prism along the cross-section, you get always the same exactly two-dimensional figure. So they are congruent, we call it, okay? So imagine this loaf of bread, for instance. If you cut it along that cross-section, you will always get exactly the same shape and the same size. So prisms are always called according to this cross-section. So for instance, the first one, you have a rectangular prism because the cross-section is always a rectangle. And here you will call it a triangular prism, a trapezoidal prism, and depending on the shape of the cross-section, we will call them also different things. Here we have an example of not a prism, but very similar. The cross-section is a circle and we call this figure a cylinder. So how are we going to find the surface area of these prisms? It's very simple. The first thing that you have to identify is how many faces the prism has. Once you do that, then you will need to calculate the area of every single face. And in the end, you just add them up. So that will be the total surface area of the three-dimensional figure. So let's look at some examples. The first example will be this triangular prism. So you see we have this triangle at the front and at the back. Imagine if you cut out the prism along this figure, then you will always have exactly the same shape and the same size. So the cross-section is the triangle, okay? So how many faces does this triangular prism have? So you have three rectangles, the one at the bottom, the one on the right-hand side, the one on the left-hand side, and then you have two triangles at the back and at the front. So if you draw the net of this triangular prism, more or less it will look like this. So we put here all the dimensions as well. The rectangle highlighted in yellow is this one here in the middle. And then you have the rectangle on the left-hand side and on the right-hand side. Afterwards, you have the two triangles. So your task in finding surface area of this triangular prism is to figure out the area of each individual face, each individual two-dimensional face, and then we add them all up. So the first question is, how do I know this side is 5? Because here it is actually not given. So we see that this side here, this length is not given. However, I see that I have a right angle triangle here. Yeah. So here the side length is 3, and because it is an isosceles triangle, I can safely say that this side is 4, half of 8. And applying Pythagoras theorem, then I can see that 3 squared plus 4 squared should be equal to this side, I call it x squared. And then applying Pythagoras theorem, 9 plus 16, that's 25. Is x squared, so x must be 5. So that's the first thing that you need to figure out. So once I have all the dimension, then we are going to find out area of the triangle. So each triangle will be base, which is 8, times height, which is 3. So base is 8, height is 3, and then divided by 2. However, because we have two triangles, we multiply it by 2. Clearly then, the 2's cancel out. So in the end, we have just 8 times 3, which is 24. Now the areas of all the rectangles, there are 3 rectangles. The yellow one is 8 times 12, and then 5 times 12 on the right and 5 times 12 on the left. So we have here 96 plus 60 and plus 60. Then adding everything up, we will have 24 plus 96 plus 60 plus 60 Altogether, we will have 240 centimeter squared. So that's the total surface area of this triangular prism. The next thing we will have a look at is the surface area of a cylinder. How are we going to figure that out? However, we have to be very careful because we have several types of cylinder. So what do I mean by that? So imagine that I have this cylinder here. I could have an open can. So what I mean by that is you have the circle at the bottom. You have the curved surface of the cylinder. However, since it's open, there is no material here. So this is open, okay? No material necessary for the top. You have the curved area of the cylinder and you have the circle at the bottom, okay? I could also have a closed solid cylinder. So in this case, if I have a closed solid cylinder, I will have the curved area, the curved surface of the cylinder. I will have the circle at the bottom and the circle at the top. So two circles and one curved surface. I could also have, of course, a hollow cylinder. So imagine that we have a cylinder, however, there is no top and there is no bottom at all. So then you do not have two circles, you have no circle at all basically, and you have only the curved surface of the cylinder. Can you imagine that if I cut it along a vertical line, a straight upright vertical line, this hollow cylinder, when I open it up, this will be a rectangle. This will become a rectangle. So when I'm looking for the surface area of this curved cylinder, the curved part, it will actually be an area of a rectangle. You see that? So imagine again, if this is my cylinder, you see, and this is the height of the cylinder, that will be the height of the rectangle as well. You see that? And the length or the base of the rectangle, so the horizontal part here, actually used to be, when it was a 3D cylinder, used to be the circumference of the circle. So the circumference of the circle will be the length of the rectangle, and the height of the cylinder will be the height of the rectangle. So knowing that, we'll go back and figure out surface area of cylinder. So first, let's look at the hollow cylinder. As we said before, when you open up or cut it along the vertical line, this hollow cylinder, the curved part of the cylinder is no more than a rectangle. And the height of the cylinder is the height of the rectangle. And we figured out that the length of the rectangle used to be the circumference of the circle when it was a cylinder. And circumference of this circle, of course, is just 2 pi r. So here the length is 2 pi r of the rectangle. So obviously, when I want to know the area of this rectangle, then I just have to multiply the base, which is 2 pi r, by the height of the rectangle, which is h. So curved area of a cylinder is then 2 pi r h. So depending on the question you get, you have to think about it yourself. If it is a hollow cylinder, then you just safely use this formula in your formula booklet, 2 pi r h. However, if you get some other questions, so for instance, think of the Pringles open can. If you have a cylinder with a base, but no top, no cover, then you have to remember, you have to assemble the formulas yourself. Here is just the curved part of the cylinder, but you have to remember to add on pi r squared because you will have this circle here at the bottom. Now, if you, let's say, have a closed solid cylinder, you will have both top and lid or cover. Then you have to remember that you have to add 2 circles area. So you will have 2 times pi r squared because you have 2 circles, one at the bottom and one at the top. So remember, of course, there is a formula booklet. However, you have to know which one to use and how. So in the formula booklet, surface area given is just the curved part of the cylinder, 2 pi rh. Then depending on the question, whether it's hollow or with 1 circle or 2 circles, you will have to figure out yourself what you need to add on. So good luck and try all the exercises in the practice today and have fun!